Morning, everyone. This is our start of the new topic of simple chemical reactions. And the first topic that we're going to do is the difference between physical and chemical changes. I did ask you the other day to list down or to even read through this topic here and place it on a table form to compare the difference between physical and also chemical. So today we are basically going to discuss about what's the difference between a physical and what's the difference between a chemical reaction. Let me just put this window away for a short while. Okay, should be fine. Yep. So we know that all chemical reactions that you see in life will have two different types of changes. One is a physical change and the other is a chemical change. So how do we identify physical changes? If we look at this glass here being shattered, you will notice that the glass is still the same substance. The only difference here is the form changes from a beautiful, pure glass that you can see here to something that's shattered into pieces. But this process here of physical changes is often reversible because it does not produce a new substance and it only changes on its physical appearance. So if you remember the glass here, as long as it is not changing to a new substance, that is the key pointer of any physical changes. Yeah. And what are the physical changes in terms of the evidence? It only changes the shape or form. So if you can look at the pictures over here, you notice that the shape and also the form has been changed. And if we can connect this to the forces that you have learned before, you will definitely note that it definitely requires a force to change the shape or form of an object. We have spoken about changes of state, right? The different states of matter, and that would be solid, liquid, and gas. So as you can see over here, it only changes its physical appearance, it only changes its state, whether it's solid, liquid, or gas, either or are basically or more or less the same in terms of the appearance. Yep. So we are talking about the changes of the state in terms of solid, liquid, and also gas. Another one that we talk about here would be expansion and also contraction. You will notice from the heating and cooling topic, it links very well by the expansion and also contraction. You will notice that the railway tracks have gaps so that it allows the expansion. Now, does the railway gap change? No, it doesn't. So it is considered a physical change, not a chemical. Right? So what I meant by change just now, does it change chemically? Was a new product being formed? If there are no new products formed, they are basically physical changes. All right. The only thing that would change, the only thing that is an exception is water. So you might think that expansion occurs when heat has been provided. Well, actually, for water, it expands when it freezes. I'll talk about this later in the class, but it gives you a good idea to think why it happens so. And the other example would be hot air balloons. And as you know, the hotter the air, the less dense it is. Hence, it rises, right? So if you can link all this to your previous topics, you're on the way to go here. Right? Mixing is another physical change because you are not really forming a new product. You are still having the same product, it's just that it's been mixed, and there are different ways for you to separate these substances. All right, now we go to the chemical bit. Yeah, so chemical changes, as opposed to physical changes, are often irreversible. That means if the reactants have reacted or the substances have reacted, you will definitely produce a new substance. So remember, the big underlying difference between chemical and physical changes is that one produces a new substance, the other doesn't. Yeah. Now, I will do this activity of changing water to wine, right? And also the elephant's toothpaste during your classes. So please look out for it, all right? Okay, one of the components over here of a chemical change is the change in color. So as you can see over here, the leaves change color. That's a chemical reaction. You can see red wine and white wine. right? These are chemical reactions if they react with one another because a new product has been formed. All right. Another thing that you can see is the production of gases. When we will do this in the later part, the formation of hydrogen gas, carbon dioxide gas, and oxygen gas. Precipitate is basically insoluble salt. Yeah, is basically insoluble salt. Henceforth, you will notice that this is what we call a reaction that occurs, right? It's a chemical reaction. So as you can see on the left-hand side over here, this is actually what we call golden rain, and it is actually lead 2 iodide formed from the two elements lead, metal, and iodine gas. So if you add the two together, they form a new compound. That's a chemical reaction, right? And you can see a white, cloudy, insoluble substance here. This is basically a precipitate. Yeah, we will do all of these in the future experiments so that you will understand what it means by a chemical reaction and a physical reaction. Sorry, not, let me just take back. It's chemical changes, okay? Not chemical, well, indirectly is reactions, but put it this way, chemical changes, evidences of chemical changes. Light or heat being released. This here are two common ways also for you to know that chemical changes have occurred, right? So have a look at this one here. You will have a solution inside with phenyl oxalic acid and fluorescent dye. And this is basically the glow sticks. The moment you break it, all right, the moment you break the glass vial inside here, you will release the substances which will react with different substances to produce the light. And this is non-reversible. So it's irreversible. Okay. Now you notice over here, you have all the smoke is what we call effervescence. All right, we'll talk about this in class if you're not sure of the new terms. But effervescence is spelled as E-F-F-E, effer, V-E, V, S-C-E-N-C-E, sense, effervescence. All right. And one example of a chemical change here. This is found in live I would say not life, sorry, airbags, car airbags. Yep. So inside there, the gases will actually be reacted, or substances inside will be reacted, and you will eventually form this part of the airbag in cars. So what I mean by that is sodium azide, NaN3, is the substance initially. So the substance initially, after undergoing a certain change, right, a certain pressure, a certain execution, it will break down into sodium and nitrogen gas. This nitrogen gas here basically fills up the airbag in your car. So happens if there is an accident or a certain force that hits it. Yeah? So you can read this basically on your own, and this information is found on your Google Classroom. Just go through the slides, right? I will tell you which textbook later in class so that you can refer to know what a physical and chemical change is. Okay? All right. Thank you for listening.